Okay, Assalamualaikum warahmatullahi wabarakatuh, and good evening. So for this evening, we will discuss the second last of subtopic of Laplace transform. So we will discuss how to find the inverse Laplace transform of partial fraction. Right, so what is the partial fraction? Partial fraction play an important role in finding inverse Laplace transform. The decomposition of a rational expression into component fraction can be done quickly by means of single command on most computer algebra system. So if you use the computer, then it is very easy to decompose the fraction into partial fraction, but because we are doing exam in the hall, you cannot use any computers to do this, so we need to do hand by hand. So the decomposition of partial fraction into a fraction is very important. It plays very vital role in solving the differential equation. So today we will look a few different method how to decompose the fraction into partial fraction. So for example, we have a fraction that contain the denominator as a linear factor. So if you observe the fraction, in order to solve the fraction, first we need to make sure that our fraction is rational function. So kita mesti make sure our fraction is a rational fraction. So what is a rational fraction? A rational fraction is a fraction that the power of numerator less than the power of denominator. So if you have, for example, fraction fs equal to s plus 1 over s minus 2, this is not rational fraction. So this is not rational fraction. Why? Because the power of the variable s are equal with the denominator, power of s in the denominator. So we must convert this fraction into rational fraction. So how to convert this fraction into rational fraction? So you need to do long division. So I will not discuss how to do the long division here, but I will ask you to look at yourself how to do the long division. So we want our fraction to be less, the power of fraction to be less power in numerator than denominator. For example, s plus 1 over s squared plus 2s plus 1. For example, we have this function. So this is a rational function. Why? Because the power of s in the numerator are less than the power in the denominator. So if we have a function like this, then we may proceed to decompose it into the partial fraction. But if we have a function like this, where the power of numerator s and the power of denominator s are equal in denominator, then you need to do the long division. You need to divide s plus 1 divided by s minus 2 by using the methods of long division. So now look at the first fraction. If we have a function that contains the denominator as a linear function. So linear function mean the power of denominator, the highest power is 1. Then the numerator must have a constant. The power of a must be 0. That means s to the power 0 is 1. So a must be a constant a. Same with this one. So we have cs, where s is the power 1. That means the numerator must be constant. So this is called linear factor. If we have, for example, like second fraction here, a over a s plus p, this fraction is okay because this is a linear fraction where s is the power 1. And the second fraction here, the highest power is 2. So the numerator must be linear, must be less 1. So bs plus c. So we want to convert our fraction into this type of form. So this is called quadratic factor. For example, let's see the partial fraction of this example number 3. So evaluate the inverse Laplace transform of s squared plus 6s plus 9 over s minus 1, s minus 2, s plus 4. So if we have a fraction like this, so where the denominator actually, we have s minus 1, s minus 2, s plus 4. Actually, this is s to the power of 3. Then we want to decompose it into a few fractions. So how we do this fraction? So we have s squared plus 6s plus 9 divided by s minus 1, s minus 2, and s plus 4. Alright, so the rules say that first, this fraction can be broken into 3 parts because we have 3 of s in the bracket. So first, the first numerator will be s minus 1. Second will be s minus 2. And third will be s plus 4. Since we want the numerator, because this is a linear function, so the numerator must be constant. So let's put here a, here will be b, here will be c. And then we want to decompose it into the function. So let's write the original function. So s squared plus 6s plus 9 divided by s minus 1, s minus 2, s plus 4. This is equal to, so s minus 1, s minus 2, s plus 4. All right, so first, let's see the a. So a, we already have s minus 1. That means if we want to expand this fraction, we need to multiply s minus 2 and s plus 4. So write a multiply s minus 2, s plus 4. Then b, so b we already have s minus 2. That means we need to multiply with s minus 1 and s plus 4. So b multiply s minus 1, s plus 4. And third, c, so multiply with s minus 1, s minus 2. Alright, now we observe that this fraction and this fraction are equal. Both are the same fraction. Just we have broken into 3 parts. So we have broken into a times s minus 2 plus 4, b times s minus 1 plus 4, and c times s minus 1, s minus 2. So we need to find what is the value for a, b, and c. Since the denominator of both fractions are equal, then we can say that the numerator are also equal. So we can write the numerator as s squared plus 6s plus 9 equal to a s minus 2 times s plus 4 plus b times s minus 1 s plus 4 plus c s minus 1 times s minus 2. Alright, so there are a few methods how to find the A, B, and C. One of the method you can do is you may expand this one. So you times A times S minus 2 times S plus 4. So you expand S squared minus 4S minus 8 and so on. And then you solve the simultaneous equation. Second method that I will show to you for this evening, is more simplest method. So we proceed by this method. If you see this fraction, so we have here s minus 2, s plus 4, s minus 1, s plus 4, s minus 2, s minus 2, s minus 1, and s minus 2. So let's take, for example, we want to cancel this a. To make it simple, let's make this bracket equal to 0. So how about let's take s equal to 2. If we put s equal to 2 here, that means 2 minus 2 will be 0. Hence, a times 0, 0. That means this one will become 0. And we also have here s minus 2. If we substitute 2 here, that means c also goes to 0. Here will be 0, here will be 0. So you substitute 2 here, 2 here, and substitute 2 here. So you can find the answer for B. So let's do that. Let's take s equal to 2. So for the left-hand side, so we have 2 square plus 6 times 2 plus 9. So now A, if we substitute 2 into S here, this one will become 0, and this one also will become 0. We substitute 2 here. So this one is 0, 0. So now we have B equal to 2 minus 1 equal to 1. 2 plus 4 equal to 6. So on the left hand side, we have 4 plus 12 plus 9. So we have 25. On the right hand side, we have 1 times 6, 6. So 6b. That means b equal to 25 over 6. All right. Let's substitute s equal to 4 minus 4. If we substitute s equal to minus 4, that means b will be 0. A also 0 because we have s plus 4 here. So substitute s equal to minus 4, s minus 4, this one will be cancelled out. That means we can find the value for C. So let s equal to minus 4. So for the left hand side, we have s squared, so minus 4 squared plus 6 times minus 4 plus 9. So A0, B0, so C minus 4 minus 1 is minus 5. Minus 4 minus 2 is minus 6. So we have on the left, on the right, we have 6 times 5, 30C. So 16 minus 24 plus 9. This is equal to 1. Hence C equal to 1 over 30. And lastly, to find for A, so we want to solve for A, we already have B and C. So A, let cancel this one because we have S minus 1 and S minus 1. So let S equal to 1. So if we put S equal to 1 here, so on the left hand side will be 1 square plus 6 plus 9 equal to, so here will be 0, 0, B, 0, A, 0, A time minus 1, sorry, 1 minus 2 is minus 1. 1 plus 4 is 5. So minus 5 equal to 10, 16. So minus 5A. So A equal to 16, then minus 16 over 5. So now we know A, B, and C. Hence, we can substitute into this fraction. So we know A is minus 16 over 5. B is 25 over 6. C is 1 over 30. Hence, I can write our Laplace transform. So S squared plus 6S plus 9 over S minus 1, S minus 2, S plus 4. This is equal to S minus 2, S plus 4. So A just now is minus 16 over 5. B is 25 over 6. C is 1 over 30. Then by using the linearity, so 16 over 5 minus 16 over 5, I can put outside. So I will have 1 over S minus 1. Same with 25 over 6, I can put outside. So I will have 1 over S minus 2. And lastly, 1 over 30, we can put outside. So here will be 1 over S plus 4. Okay, referring the Laplace table, 1 over S minus 1, this is exponent T. So we have 16 over 5 times exponent T plus 25 over 6. So 1 over S minus 2 is exponent 2T. 1 over 30 is exponent minus 40. So that is the answer. So that is how we break down the partial fraction. So how we decompose the partial fraction. So from this fraction, we can find the inverse Laplace transform by using the partial fraction. So we will get this answer. And let's try exercise number 3. Question number 1. So exercise number 3. So A, we have Fs equal to S minus 3 over S minus 2. So we want to find the inverse Laplace transform. So we will write S minus 3 over S minus 2. First, let's break down the fraction into partial fraction. So let's write S minus 3. We want to decompose into the partial fraction. So we have first one we have s, second one we have s minus 2. All right, so for the first one, because this is s, a linear factor, so we must have the numerator equal to a. For the second part, s minus 2, because s also linear, hence the numerator will be b. Then we want to expand this fraction, so s minus 2. So a will be multiplied by s minus 2 and b will be multiplied by s. So you cross multiply. So a over s plus b over s. So we cross multiply. A times s minus 2, b times s over s, s minus 2. So this is equal to s minus 3 over s, s minus 2. Right, so because the numerator here are equal, then we can say that s minus 3 are equal to a times s minus 2 plus bs. So s minus 3 equal to a s minus 2 plus bs. Oh, all right. The same strategy to find the answer for a and b. We look here, we have s minus 2. Let's make a equal to 0 by substituting s equal to 2. So let s equal to 2. That means on the left hand side here, s minus 3. So 2 minus 3 is minus 1. So a will be 0. B will be 2b. So b equal to minus 1 over 2. And then to find for a, you can use any numbers. You can substitute, let's say, let's take s equal to 1. So 1 minus 3 equal to minus 2. A we know, B we already know, minus 1 over 2 times 1. That means A here will be A times 1 minus 2 is minus 1. B is minus 1 over 2. S is 1. So we will have minus 2 equal to minus A minus 1 over 2. So minus A. So A will be minus 1 over 2 plus 2. So 1 over 1 over 2. Now we know that B equal to, or A equal to 3 over 2 for simplification. So now substitute into our fraction. Which fraction? This one. So we have a Laplace transform of s minus 3 over s minus 2. This is equal to Laplace transform of A 3 over 2 over s plus B minus 1 over 2 over s minus 2. Okay, so let's take this one. All right, now let's put 3 over 2 outside. So we have Laplace of 1 over s minus 1 over 2 Laplace, inverse Laplace of 1 over s minus 2. So 1 over s is 1. So 3 over 2 times 1, this one, minus 1 over 2 exponent. So s minus 2 is exponent 2t. So the answer is 3 over 2 minus 1 over 2 exponent 2t. Alright, let's see question, more complicated question. Let's try question number C. Yeah? Let's try to do this one. Okay, I will use new pages. So let's try C. So Fs equal to s plus 2 over s square minus 3s plus 2. So we want to find the inverse Laplace transform for Fs. So we want to convert this into t, equations of t, yt, ft. So let's find the inverse Laplace of s plus 2 over s square minus 3s plus 2. Alright, first we want to decompose this fraction into partial fractions. So let's write the fraction first. S square minus 3s plus 2 into fraction. So first let's observe the denominator, this one. Can we factorize this fraction, this quadratic expression? So we can decompose into factorize. We can compose this one into s minus 1 times s minus 2. So if I expand, I will get the same thing with the left hand side. So here will be s plus 2. Now I want to decompose it into two fractions. So let's write the first one s minus 1, second one s minus 2. So here we have linear. That means here will be A. Second one we have also linear. Here will be B. So s plus 2 over s square minus 3s plus 2. So we want to solve for A and B. Now let's expand the bracket here. So here will be s minus 1, s minus 2. So cross multiply. So A multiply s minus 2 plus B multiply s minus 1. So here we have A times s minus 2 plus B times s minus 1. So this is equal to s plus 2 over s square minus 3s plus 2. So because both numerators are equal, hence we can say that this one and this one are equal. So s plus 2 are equal with A times s minus 2 plus B times s minus 1. Right, so we employ the same strategy. So let's substitute s equal to 1. So if I substitute s equal to 1, left hand side will be 1 plus 2 equal to 3. So A, 1 minus 2 is minus 1. B will be 0. So 1 minus 1 is 0. That means A will be minus 3. So to solve for B, let's cancel A. So how to cancel A? Let's put S equal to 2. So we have 2 plus 2 equal to 4. Here A will be 0. B will be 2 minus 1 equal to 1. So B equal to 4. So we have inverse Laplace transform of s plus 2 over s square minus 3s plus 2. This is equal to inverse Laplace transform of a is minus 3 over s minus 1 plus 4 over s minus 2. Alright, so we put minus 3 outside, find inverse Laplace of 1 over s minus 1 plus 4, 1 over s minus 2. Alright, so I will write the answer here. So we have minus 3. 1 over s minus 1 is exponent t plus 4. 1 over s minus 2 is exponent 2t. So this is our final answer. Minus 3 exponent t plus 4 exponent 2t. So we don't have quadratic equation lagi ya. Kita tak jumpa lagi yang quadratic equation. Let's try to find a quadratic equation. For example, alright, for example 26. Okay, we will do one more exercise. Let's see example 26. So we have s over s plus 2 times s squared plus 4. So this one is quadratic expression. If we decompose the partial fraction here, we will have first we have linear, second we will have quadratic. Let's do this one. So exercise 7.2, question number 26. So we want to find the inverse Laplace of s over s plus 2 times s squared plus 4. Right, first, let's break down the fraction into proper fraction or rational fraction. So let's write s over s plus 2 times s squared plus 4 into functions or fraction consists s plus 2 over s squared plus 4. Alright, so for s plus 2, because this is linear is the highest power equal to 1. That means the numerator will have a. We have a constant. For second part, we have s squared plus 4. So this is quadratic equation. So we cannot have b. Because this is quadratic, here we must have a linear equation. So the linear equation will be bs plus c. We have bs plus c. So we expand this one. So s plus 2 multiply s squared plus 4. So a will multiply with s squared plus 4 plus bs plus c will multiply with s plus 2. So here will be s plus 2, s squared plus 4. So since s squared plus 2, s squared, and s plus 2, s squared plus 4 are equal with this one, that means this one and this one are equal. So we can write s equal to a multiply s squared plus 4 plus bs plus c multiply s plus 2. Right, so we can employ the same strategy, but this strategy, we cannot make it a equal to 0 because here we have s square. So you cannot make it this one equal to 0. You only can make it b and c equal to 0. So you can only find a, but you also can find by using the same technique. So let's first find a. So to find a, we must make b and c equal to 0 by setting s equal to minus 2. So let's make s equal to minus 2. So if s equal to minus 2, that means here will be 0. So bs plus c times 0 will be 0. So s on the left hand side is minus 2. A will be, so minus 2 square is 4. 4 plus 4 equal to 8. So 8. So A equal, sorry, this one also minus 2. So A will be minus 2 divided by 8. So minus 1 over 4. So we have A equal to minus 1 over 4. All right, now let's solve for B and C. So we need to solve for simultaneous equation. So let's take s equal to 0. So what happens if I let s equal to 0? So on the left hand side here, so this one is 0. A will be, A we know equal to minus 1 over 4. So let's write minus 1 over 4. So s squared, so 0 plus 4. B will be 0, B times 0. So we have C. So 0 plus 2. So times 2. 0 plus 2 is 2. So we will have minus 1 A plus 2C. So 1 equal to 2C. So C equal to 1 over 2. Alright, now let's take S equal to 1. So I will write here. Let's take S equal to 1. So here will be 1. A is minus 1 over 4. So minus 1 over 4 times 1 plus 4 equal to 5 plus B. B, sorry, B we don't know. So we have B times 1 is B. C is 1 over 2. So plus 1 over 2 multiply 1 plus 2 is 3. So multiply 3. So let's expand this one. So we have 1 equal to minus 5 over 4 plus, here we have B plus 1 over 2 times 3. So 1 plus 5 over 4 equal to 9 over 4. 9 over 4 equal to B plus 1 over 2 times 3. So we divide by 3. So we will have 9 over 4 divided by 3. 3 over 4 equal to B plus 1 over 2. So B equal to 3 over 4 minus 1 over 2. So minus 2 over 4. So this is equal to 1 over 4. One over 4. All right, so A is minus 1 over 4, B 1 over 4, C 1 over 2. Hence, I can write the inverse Laplace transform of S over s plus 2 times s squared plus 4 as inverse Laplace of a. So what is our original function? So a is 1 over 4. So 1 over 4 over s plus 2. B 1 over 4 s 1 over 4 s plus c is 1 over 2 over s squared plus 4.
Sir,
Yes?
yang A tu sir tertinggal negatif.
Let me check. A minus, okay. Minus 1 over 4. Okay. Alright, so we have inverse Laplace of 1 minus 1 over 4 over s plus 2 plus 1 over 4s plus 1 over 2 s squared plus 4. Alright, so this one, you can use the same method as we already learned just now, as I already showed. This one, because in the table we don't have s plus some function, that means we need to divide this one into two fractions. So if I divide this into two fractions, I can write this one as, so let's break it into this one, 1 over 4 over s plus 2 plus inverse Laplace of 1 over 4 s over s squared plus 4 plus inverse Laplace of 1 over 2 over s squared plus 4. Okay, let's copy this one first. Okay. So we can put 1 minus 1 over 4 outside. So we will have minus 1 over 4 inverse Laplace of 1 over s plus 2. So here we have 1 over 4 outside, inverse of s. So here will be s squared, 4 will be 2 squared. And the last one, we will have 1 over 2 outside. So we have inverse Laplace of 1 over s squared plus 4 is 2 squared. So because in the table we have k over k squared, so here must be 2. Because I put 2 here, that means here must be divided by 2. Alright, now by referring the Laplace table, 1 over 4, so 1 over s plus 2 is exponent minus 2t plus 1 over 4. So s over s squared plus 2 is cos. So this is cos 2t. And then here 1 over 4 also. 1 over 2 divided by 2 is 1 over 4. This will be sine 2t. Right. So that is the answer. Alright, so we have another 30 minutes, so I will send you the link for, I forget to send you the link for attendance. Alright, so please fill in the attendance form. You may find it in the message. So fill the attendance form first. So I will continue. We take break 5 minutes. We will continue at 9:30. So let's take 5. Alright, so let's continue our lesson. Alright, just now we already see that our fraction consists of a linear and quadratic equations. So just now we seen that if our fractions consist of linear and quadratics, then we can break down the linear and quadratic into two equations. Now let's see if we have a repeated linear factor. So it may be a linear factor or it may be the quadratic factor. So what is a repeated linear factor? So we have a fraction that the denominator is as plus b. So you have a number as plus b, and then plus the same number as plus b, but now it is a repeated, but now it has the power. So it now became power 2. And it may be repeated for third time with power 3 or power 4 or power 5. So how to do this one? For example, we look at the example number 2. So we have find the inverse Laplace of 2s plus 5 over s minus 3 square. So this is a repeated. So you may write this one. You may write this one as we already done just now. 2s plus 5 over s minus 3 square. You also may write this one as s minus 3, s minus 3, 2s plus 5. Then you can break down this fraction, s minus 3. This one will be a, here will be b, s minus 3, and then you can solve as usual, as we already done just now. But here we will use the another method to break down this partial fraction. So we will use this method. So a repeated linear factor is a term s minus a to the power of n, where a is a real, so a must be real number. You cannot have complex number I. You cannot have a complex number I. A must be real number, and n must be positive integer 2 or greater. So n must be greater or equal to 2. 3, 4, 5. We know that if s minus a to the power of n appears in the denominator of a rational expression, then assume the composition contain n partial fraction with constant numerator and denominator. S minus a square, dot, 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 until s minus a to the power of n. So, hence with a equal to 3 and n minus 2. So, just now, by using this method, we also can decompose this fraction into this type of function. So we have 2s plus 5 over s minus 3 square equal to a over s minus 3 plus b minus 3 square. By putting the two terms on the right hand side over the common denominator, so we may obtain a equal to 2 and b equal to 11. So let's show this one. So we have 2s plus 5 divided by s minus 3 square. So now we want to break down this partial fraction, 2s plus 5 over s minus 3 square. So we want to break down this repeated linear. So you may write here s minus 3, and then second is s minus 3 square. So here will be a, because here is linear. Here also linear, so we have b. So a over s minus 3 plus b over s minus 3 square. Or you can also use the previous method. So the previous method that I just show you, this one is equal to s minus 3 times s minus 3. Alright, I will show you this method. So how to break down this one? So because here we have s minus 3. If we want to cross multiply, if we want to add these two fractions, that means this side we must multiply s minus 3, right? We must multiply s minus 3. So if we multiply denominator with s minus 3, that means numerator also s minus 3. This side, we don't need to multiply with anything because we already have s minus 3 square. So here will be s minus 3, here will be b. So 2s plus 5 over s minus 3 square. Since both denominators are equal, then we can say that 2s plus 5 is equal to a s minus 3 plus b. Alright, now let s equal to 3. So 2 times 3, 6. 6 plus 5, 11. A will be 0. So 3 minus 3 is 0. So we get b equal to 11. Let s equal to 1. So 2 times 1, 2 plus 5, 7. A, we want to find what is a. So a times 1 minus 3 is minus 2. B is 11. So 7 minus 11 is minus 4 equal to minus 2a. So a is 2. Hence the Laplace transform of 2s plus 5 over s minus 3 square is equal to Laplace transform of, substitute a here, a is 2, so 2 over s minus 3. B is 11, so 11 over s minus 3 square. So 2 is constant, so we can put outside. So here will be 1 over s minus 3. 11 also constant, we can put outside. So we have 1 over s minus 3 square. Alright, rather than write s minus 3 square, this one also can be write as 1 over s square, where s is s minus 3. If I substitute s minus 3 here, that means I will get s minus 3 square. So here will be 2, 1 over s minus 3 is exponent 3t plus 11. So s minus 3 is exponent 3t. 1 over s square is t. So we have 2 exponent 3t plus 11 exponent 3t times t. So this is our answer. Okay, let's try eleven. Okay, let's try question number 11. It looks like a simple question, but how we want to solve this one? So let's write question number 11. So find the inverse Laplace of 1 over s plus 2 cube. So actually I don't need to decompose it into partial fraction because we have the coefficient here equal to 1. I just can, let's do this. I just can let this is equal to 1 over s3. Here will be s plus 2, right? And then, so we have inverse of, so we need here to be equal to 2. That means I need to divide by 2. So 1 over 2, 2 over s to the power of 3, where s is s plus 2. So 1 over 2, here will be exponent minus 2t. Here will be t square. That is the answer. So we don't need to decompose this function into fractional function, fractional division. So just solve as this one. So inverse Laplace of 1 over s plus 2 cube. So no need to decompose this one into the partial fraction. So this is the answer. Let's find one exercise that we can solve. Number 12 also, you no need to differentiate, you don't need to decompose this function into partial fractions because we have here 1. Let's try number 17. Number 17. So find the inverse Laplace of s over s plus 1 square. Alright, so we want to decompose this function into partial fractions. So s plus 1 square is a over s plus 1 plus b over s plus 1 square. So this one will be s plus 1 square. So here we multiply a with s plus 1 and b we don't multiply with anything. So here will be s over s plus 1 square. So both numerator are equal, then we can say that s equal to a s plus 1 plus b. So substitute, let's say s equal to minus 1. So we have minus 1 equal to b. So b is minus 1. So let s equal to 1. So we let s equal to 1. So we will have 1 equal to 2a plus b. b is minus 1. So 2a is 0. 2a is 2. So a equal to 1. So substitute a equal to 1, b equal to minus 1 into this fraction. So we have inverse Laplace of s over s plus 1 square. This is equal to inverse Laplace of 1 over s plus 1. b is minus 1, so minus 1 over s plus 1 square. So here we have inverse Laplace of 1 over s plus 1 minus inverse Laplace of 1 over s plus 1 square. So 1 over s plus 1 is exponent minus t. So here will be 1 over s square is t. So this is, so let's write this way. So here will be 1 over s, where s is s plus 1. So 1 over s square is 1. So s plus 1, here exponent minus t. So 1 over s square is t. So that is our answer. So number 17. Exponent minus t minus exponent minus t times t. Alright, so we have covered the partial fraction. So this is the last one before we can solve the differential equation. So I will discuss this one in our class. So next week we will discuss the midterm first, and then I will discuss this theorem, and then we can conclude the Laplace transform chapter 3. And then on the Wednesday at 8:30 you will have the quiz 2. So you need to do exercise. So please read the properties of the Laplace. So the properties of Laplace you can refer in the notes that I have given to you. I will also give you some question that reflect the quiz that you will take in this coming next week. So I will give you the quiz, and then I will give you some question or some tutorial that resemble the quiz that you will be taken. So I hope that with that question, with that tutorial, you may perform well in your quiz, because you need a lot of carry mark to carry over before you take your final exam. So with that, I think I have concluded our lesson for this evening. Any question before we dismiss? Ada soalan tak? Okay, so if we don't have any question, we will stop our class here. I will send you the link for our recorded classes. I hope that you will use the Cengage to find the tutorial. If you didn't find any tutorial, you also can do a lot of questions from the ebook that you can open in your Cengage. So I will for these 2 weeks I haven't opened our Cengage. Saya tak sempat lagi nak buka Cengage sebab I have so many works to do. I cannot check the Cengage. Okay, I think that's all for this evening. With that, thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.